on. Good afternoon, everybody. Welcome to rainy Monday afternoon at Chem 170 with your host, me, Dr. White. It's our last week together. Next week is, they don't really call it that, but I'll call it finals week. And our last week together. I hope you've had a good time learning about my world of organic chemistry, which is now your world of organic chemistry. All right, we got a lot to do today. All right, let me give you a heads up. First of all, today I'm going to go through test number 4. I gotta get that finger fixed. Test number 4 answers. Then, or actually before that, I'm going to go through the final exam, talk about that. We'll do test 4, go through that with the answers. And then after that, I will start doing the review for the whole semester. So let's get going. All right, first thing I wanted, let me just do one thing. All right, let's talk about a week from today will be the final exam for Chem 170. You should have gotten this as an email. It's an announcement on D2L. All right, next Monday at 1 p.m., and I might even shoot out the email with the password a lot earlier, I will be giving the final exam. You'll have until Tuesday, the 16th, 3 p.m., take the final exam and upload your answers, a single PDF file. I reserve the right to subtract up to 50 points for anyone who does not follow instructions. That hasn't happened this class. The other class, I had a few who were sending me JPEG files, and I don't like dealing with that. It's a lot of extra work. All right, take as much time as you need to finish the final exam. Most students in my, if we were face-to-face, a similar final exam, usually 75 to 90 minutes. Relax, students do good on my final exam. All right, again, this is not an open notes test. Now, don't get scared. It's got 32 problems, 18 pages. Some of the problems are multiple part. As you know, I've never will give multiple choice in Chem 170. And the point breakdown is general knowledge, 30 points, nomenclature, 62, reactions, 118. And nomenclature are mainly, here's the compound, give the IUPAC or some of them common name, or here's the IUPAC or common name, draw the structure. Reactions, most of those will be give the reaction, give the organic product or products for the following. A few will be give the starting materials. Now, I've also broken it down on points based on the material of each of the 4 tests. Now, test 1 is 35 points. Why so little? Well, I'm not going to ask you at this point how many carbons are in the longest chain. You know how to do that for the rest of the nomenclature. So that's some of the questions I don't, from test 1, I don't put on the final. But you should know the chemistry and some of the general knowledge. Test 2, 60 points. Test 3, 58. Test 4, 53. They're about equal. And new material, which is amino acids and proteins, 4 points. It adds up to 210. There's 10, 10, 10 bonus points. And if you have any questions, email me. We will not have a normal Zoom lecture on that Monday. No, you'll be taking the final exam. And the best way to study for the final exam, just like my hourly exams, are do the practice problems. Look at the reviews. That will help you. Now, by the end of Friday of next week or earlier, I will have in D2L, I will post your final, all your scores, and also your final grade. Now, it usually takes from the time I put it in the official ECC, what do they call it, my ECC or Access ECC, whatever, I forgot. Each school has a similar name and I get them mixed up. Usually takes about 24 hours for you to see it officially, but what I have in Blackboard, you can count as official. Now, one of the things I don't do, and I don't do this when I'm face-to-face either, I am not going to send out an email with your individual scores on your final exam. If you are within about 10 points of a cutoff, I go back and regrade the whole test to make sure I haven't made a mistake. And I haven't, in all the years, I haven't made a mistake that made any, maybe 1 point, but 1 point is going to make the difference between A and B or B and C. All right. Any questions on the final exam? Looking down there at the chat, see if anybody has sending me a chat message. All right, now, one thing I should explain, ECC doesn't have an official finals week. And because the contract, the way it's written with the faculty, both adjunct and full-time, and the school, next week, quote unquote, I have to have classes. So I'm going to be here next Monday, even though you should be taking the final, Zoom for about 15 minutes. And after the final on Wednesday, I have to come here for a Zoom meeting for about 10, 15 minutes. If you don't want to show up that following Wednesday or the Monday, you don't. If you want to stop by, say hello to Dr. White, that's all. Please do. But I'll only be here for about 15 minutes. Both days I will have my office hours. And I think that's about it in terms of the final exam. And I'd like to thank you all for being in my class this semester. The bad thing about Zoom meetings like this is I don't get to know most of you the way I would if we were face-to-face, because during the lab time, I have time to walk around, get to know you. Well, but that's just life. And safer, I think the pandemic is winding down, but I still wear a mask because I'm in that high-risk group. All right. With that, any questions about test number 4? All right, now what I'm about to do, excuse me, is show you how many points you need on the final to get a certain grade in my class. Now listen carefully. This assumes you've handed in all the labs. Again, what I'm going to show you assumes you've handed in all the labs. If it hasn't, then you've just got to do the math yourself totally. And you can see that in the syllabus. Now, let's take a look at the following. hopefully before Wednesday, by the end of the week, I'll have the extra credit graded, but I haven't done it yet. I've been busy. All right. X is the sum of your 3 highest tests plus your extra credit project. To get an A, subtract 450 minus X, and that gives you how many points you need on the final exam to get an A. Again, this is assuming you've done all the labs, and most of you have, and I'm not a hard lab grader. You know that by now. Labs are meant to learn, not to lower somebody's grade, in my mind. To get a B, 400 minus X is the points you need approximately to get a B. For C, 350 minus X. Now, let's take a look at, let's say you did really good and you didn't do the extra credit and you got 100 on each test and you didn't do the extra credit. So 3 times 100, 450 minus 300 equals 150 points. You look at that and say, oh, 150 points. What? The final is 210. That's the same as 2 105 tests. So if I were to divide 150 by 2, that's the same as getting a 75 on my hourly exam. So, but it's twice as long, so that's why it's fun. And this has been fairly accurate for students to know. Now, one thing I will warn you, let's assume you've got this person who has, and some of you are in this ballpark. Oh, I only need 175 points, 150. That's like a 75 on the hourly exam. I don't have to study that hard. And they don't. And they do badly on the final exam. And they get a grade lower, one time, 2 grades lower than what they should have got if they studied and did the same way on the hourly exams. But they didn't because they said, I don't need a lot of points. I don't have to study hard. My advice to you is no matter what points you need, study as if you need every one. Again, don't get lazy. Study for the final exam as if you need every one. Now, I can tell you this, historically, the final exam is about my classes. If I can spell it, I try to do shorthand. I've been teaching Chem 170 long enough. Historically, my classes, and I've been blessed with very good students who follow my recommendation, the average is on the final 170 to 180, sometimes even higher, 185. That's roughly 85 to 90 average on a final, which is quite good if you think about it. Well, like I said, I've been blessed. I have very good students. Somehow I tracked them. I don't know. Must be my good looks. You didn't buy that, did you? All right. Any questions where we are right now? All right, what I'm going to be doing between now and Wednesday, don't forget, hand in the lab you did last week by Wednesday, so I can grade it and then I can put up your lab total. And that way, if you want to find the exact points, you can. But anyways, I'm going to be going through the different reviews, excuse me, I did for test 1, 2, 3, and 4. Actually, not, well, I'll do a little 4. And because I just really did it by going through test number 4 is now, but I'll go through it now and Wednesday. But what I'll do a little differently is I'll have you do some practice problems too. And if you think about it, today and Wednesday, you'll have about 3 to 4 hours of review for the final exam with me, which is why students do good on my class and my final. All right, there we are. All right, there's some definitions I asked you to learn for test 1. You should know what's a hydrocarbon, a molecule with only carbon, hydrogen atoms. I asked you to learn what's a saturated hydrocarbon, because the hydrocarbon is a molecule with only carbon, hydrogen atoms, which all, and this is important, all carbon-carbon bonds are single bonds. Unsaturated hydrocarbon, and that's a molecule because it's a hydrocarbon with only carbon, hydrogen atoms, and it contains at least one double or triple bond, or you could have written down multiple bond. We talked about, and I'll never ask you what's an alkane or cycloalkane. I taught you how to draw these. I'm not going to review that because you've already mastered that, but I will ask you to remember one of your friends on the final exam will be, remember, there's 4 bonds to carbon, 4 bonds to carbon. When I grade the final exam, about 70% of the wrong answers for reactions and other things, mainly reactions, if the student had counted how many bonds to carbon were it's changing and saw they have 3, 5, one time I think I saw 6 or 7, boy, I started laughing. How could you do that? Remember, 4 bonds to carbon, you know you made a mistake and I better do something different. All right, I talked about IUPAC, the nomenclature rules, and remember the alkanes are 1 through 10, methane, ethane, so on, decane, 10 carbons. I talked about the alkyl groups. When there's CH3 on a ring or a long chain, it's a methyl group. 2 carbons, ethyl. 3 carbons, the end of the chain attached to a ring or a long chain, and propyl. When it's attached to the center, the alkyl group is isopropyl. And then there are 2 butyl groups, N to 4 carbons, N-butyl, 3 carbons, one of my favorite, I also like isopropyl. 3 carbons attached to the center carbon attached to a ring or a long chain, tert-butyl, or as organic chemists who are lazy, T-butyl group. Before I move on, let's do one thing real quick, and maybe not real quick. And why don't you try this one? Give the IUPAC name for the following molecule. 3 points each. And let's wait for everybody to finish. All right. So the first thing you have to do is find the longest chain. 1, 2, this would be 3, 4, 5, 6, 7, but 6, 7, 8, 9, 10. I count right. 1, 2, 3. I didn't. 3, 4, 5, 6, 7, 8, 9. So longest chain is 9. That's no name. I have 2 alkyl groups. And remember, you always start numbering from the end of the chain to give the alkyl groups the lowest number. And if you start from this side, the methyl group is on 2, the ethyl group is on 4. Now, since the correct IUPAC name would be 4-ethyl 2-methyl nonane, but since I did not hold you to the alphabetical rule, that's my gift to you this semester, you'd put down 2-methyl 4-ethyl, that would have been correct also. Now, the other type of nomenclature, question? There you go. 1-T-butyl 3-isopropyl cyclohexane. And if you're stumped and you want me to go ahead, you can also vote yes, you're done. All right, let's do this. How do you decode a name? You start from the right, move left. ANE ending tells you it's either alkane or cycloalkane, hexane, 6 carbons, cyclo or ring. And every bend in a line is a carbon. On carbon 3 is an isopropyl, carbon 1 is a T-butyl. This is 1, 2, 3, isopropyl. You could have also counted counterclockwise, which other than someone like me would, you wouldn't. So there's where you have it. Now, let me remind you, when you're doing a nomenclature question where you're writing the name for ring, don't forget cyclo. Common mistake. Give the IUPAC name for that molecule. 6 carbons, student puts down hexane, I mark it wrong, because it's a ring, it has to be cyclohexane. And I see that on test 1, and I've seen it on the final. Please don't do it. All right, next, I skipped this. Here we have real uses of alkanes. Where would you find an alkane in your daily life? And would I ask a question like that? I did on test number 1. Methane, natural gas, propane for your barbecue, Vaseline, gasoline, baby oil, and candles all are alkanes or contain alkanes. Now, the only reaction I asked you was combustion. Take an alkane, and this could also be a cycloalkane. React it with oxygen, and what do you get? The actual chemicals, carbon dioxide and water. And as you learned, organic chemists are lazy. Unless I'm doing a calculation for charge weights, how much I have to mix together to make a certain amount, I don't balance chemical equations. And here the answer would be CO2 and water. And you can go back and look at the problem set and see that. All right, next on test number 1 material, alkenes, alkynes. An alkene is a carbon-carbon double bond shown by 2 lines between 2 carbons. An alkyne is a carbon-carbon triple bond, 3 lines between 2 carbons. And you should know that an alkene is made up of 1 pi bond, 1 sigma bond. An alkyne is made up of 2 pi bonds and 1 sigma bond. Now, for nomenclature, find the longest chain with both carbons of double bond. Name that as an alkane. Drop the ANE and put ENE. A number is needed for acyclic, plus if needed, cis or trans, and I'll show you that in a second. No number or cis or trans for the cycloalkenes in this class. One of the carbons of the double bond in a ring will always be 1, and the other has to be 2. Now, for a triple bond, because I haven't ever worked with, I've seen it once a long time ago in an article, but that was rare. For this class, a triple bond is always going to be acyclic. Find the longest chain with both carbons of the triple bond, and this should be YNE. Oops. Big oops. And drop the ANE, put YNE, and you need a number. The number is which carbon of the triple bond, same thing with a double bond when you need a number, is closest to the end of the chain. And the question is, give the IUPAC name of the following molecule, 3 points each. Your turn. Ten carbons. Excuse me. All right, looks like everybody's done. And as I start teaching you now, when you look at a molecule, look for something different. What's not a carbon-carbon single bond or carbon or hydrogen atom should get your attention like that. And here we have a double bond. How many carbons the longest chain? 10. Decane, double bond, drop the A and E, decene. Next, what carbon is one of the two carbons of a double bond that's close to the end of the chain? 1, 2, 3. If I go the other way, 1, 2, 3, 4, 5, 6, 7. 3 is less than 7. In case you wondered, I did count right. And so this is 3 decene, because this carbon is number 3. Now, next, since you have two of the same group or atom, one on each carbon of the double bond, you need to use cis or trans. And if these atoms, in this case hydrogen, are on the same side of a plane orthogonal, this dotted line, you can put your pencil down or whatever on your finger, then it's cis. If it's opposite on the opposite sides of that plane, it's trans. And therefore, this is trans 3-decene. And finally, oh, it's your old friend, the methyl group, and that's on carbon 5. So this would be 5-methyl trans 3-decene. And that's how you do it. If I look at the clock, it's time for a 5-minute break. Actually, we went into, so I'll see you in about 5 minutes because I'm going to get up and stretch. I'll see you in 5. All right, one of the things I didn't mention, but I would hopefully, you should have all received by now, the online evaluation. Please fill it out for me. I won't ever see it, in terms of who you are, and I won't even get them until next semester. So please fill that out. Also, if you like what I did this semester, please go to ratemyprofessor.com and write something down for me. If you didn't like what I did this semester, go to ratemyprofessor.com and write something down. Again, it's anonymous. I don't know who did it, unless you tell me, which you don't have to. All right, let's continue on with the review for the final exam, going over material test number 1. Now, there are a number of reactions I've started teaching you. And the first one is if you take a double bond, react it with hydrogen and catalyst, you break the pi bond, and each carbon of the double bond gets a hydrogen. Catalyst can be nickel, platinum, or palladium. And one of the important things I started teaching you at this point was to break carbon-carbon single bonds. In my class, except for combustion, no. And therefore, I gave you an example. And the question is, give the organic product or products for the following. I'll do this one. And you look for what's different. Pi bond, a double bond, one pi bond, and one sigma bond. And a double bond reacting with hydrogen and nickel as a catalyst. The catalyst can be nickel, platinum, or palladium. You break the pi bond, each carbon of the double bond gets a hydrogen. And this is where I started really brainwashing you. And I did. You break carbon-carbon single bonds? No. You start with 3, I better end up with 3. The only thing that changes is that pi bond is broken, and each one of those carbons gets a hydrogen. And you know there are 4 bonds to carbon, so you can put in the remaining hydrogens. And if you wanted to write that CH3, CH2, CH3, you could have, but you don't have to. Next reaction, double bond and halogen. And here I taught you organic chemists use X for halogen, chlorine, fluorine, bromine, or iodine. Take halogen gas and you don't need a catalyst, double bond, you break the pi bond and each carbon of the double bond gets a halogen. Next, I talked about the first 2 are symmetrical addition, same thing on both carbon. What happens if you have unsymmetrical? In this case, double bond, HX, where X can be chlorine, bromine, or iodine. You don't use HF, hydrofluoric acid, that's dangerous stuff. And you break the pi bond, and one carbon gets the H, the other gets the halogen, and that's based on Markovnikov's rule. And Markovnikov's rule is I'll do this one. I'm going to give you one to try too. I'm going to share the fun as I did all semester. What do we have that's different? Double bond, HCl, hydrochloric acid, HX, where X can be chlorine, bromine, or iodine. Break the pi bond, one carbon gets H, the other gets X, and it follows Markovnikov's rule. The carbon with the most hydrogens gets the hydrogen, the other carbon to double bond gets the halogen. Therefore, this has 2 hydrogens. One, wasn't the math hard this semester in my class? And which is larger? Hopefully you pick 2. You don't break carbon-carbon single bonds. Start with 3, end with 3. This gets the hydrogen because of Markov-Nikolsky rule. This gets the halogen, which is chlorine. Chlorine counts as 1 bond to carbon. And that's what you get. And here's one for you to have fun with. Enjoy. Give the organic product or product for the following. And please be patient. I've said it all semester, but I mean it. And we're face to face. I'd be saying this too. Let's give everybody a chance to finish. Finish. And don't forget, I'll be cutting test 4 answers out of the video, but I'll be posting it as a private video. And I'll send out the URL for that in an email today or tomorrow. All right, let's take a look at this. What's different? Ooh, a double bond. The rest of that is carbon, hydrogen, carbon-carbon single bonds. That's not where the action is. And we have HI, which we have a double bond reacting with HX. X can be chlorine, bromine, iodine. In this case, iodine. You break the pi bond. One carbon gets H, the other gets X, and it follows Markov-Nikolsky rule. Wait a second, I can't see the hydrogens on that ring. Well, we don't put it there. You count bonds. Let's look at these 2 carbons. This one has 1, 2, 3, 4. 4 bonds to carbon. That means that would have 0 hydrogens. This carbon right here, 1, 2, 3. 4 minus 3, it has 1 hydrogen. Do you break carbon-carbon single bonds? No. So you'll still have the ring, and you'll still have the ethyl group. Now, the hydrogen would go to this carbon, but we don't show it on a ring. There's 2 bonds to that carbon, means there's 2 hydrogens. And the other carbon with the ethyl group will get the halogen. Now, you could put the ethyl group here and the halogen there, switch them, doesn't matter for this class. In real life, it does, but not for this class. And that's how you do it. Next, I showed you a similar reaction, but now you add an acid catalyst. I taught you H plus means acid catalyst, and water to double bond. Now, double bond, you have a pi bond you're going to break. Now, think of water as H and OH. And you break the pi bond, one carbon gets H, the other gets the hydroxyl group OH. And again, it follows Markov-Nikolsky rule. Now, with a triple bond, you have 2 pi bonds. And you can break both, because it's not a sigma or single bond, which are hard to break. pi bonds I can break like that, and I have. And here, organic chemists are lazy. When we don't have to balance an equation, we don't. So here I use the letters bracket X, S, close bracket to indicate I have all the hydrogen in the world that anything that will react with hydrogen under these conditions will. So I don't have to balance it. We have 2 pi bonds. You have a catalyst, which can be nickel, platinum, or palladium. And you break the 2 pi bonds, and each carbon of the double bond gets not 1, but 2 hydrogens. For a triple bond with halogen, we do the same thing with excess. And again, since you have 2 pi bonds, each carbon of the triple bond gets 2 halogens. Next, I started talking about aromatic compounds. And the first one I talked about was benzene. And I explained how IUPAC took the common name and made it the IUPAC name. Now, benzene, there are 3 ways of drawing it. The 2 resonance forms, which I like, the calculi, I think that's cool, or the pi cloud here with the circle. If I ask draw the structure of benzene, and you do that, that's wrong. See, it even says it on the screen, because that's cyclohexane. You either have to put the bonds like this or the circle. Now, when you have a methyl group on benzene, that's not methylbenzene. That also had an old name, and that was toluene. And they made that the IUPAC name. And again, you need the bonds, and I don't know why it disappeared here. There, you need the bonds in the ring or circle. And actually, this one I don't like doing the circle. You could do that. Now, an old nomenclature that most organic chemists follow, and I do, is if you have a di-substituted benzene or toluene with another group, the methyl group counts as one of the substituents, you use ortho, meta, and para. And ortho, meta, and para means 1, 2 di-substituted ortho, 1, 3 meta, 1, 4 para. Now, I hadn't done it until now, but some other substituents, Cl chlorine on something, it's called a chloro. F is fluoro, Br bromo, iodine, I is iodo, and a new group, NO2, where the bond is to the nitrogen, is a nitro group. And here's one for you. Draw the structure of meta-nitrotoluene. Your turn. I hope you're finding this review useful. I hope you all enjoyed summer yesterday. Now we're back in late fall, early winter. I see one of your colleagues realized that you do have to study for the final exam. It's been a long semester. That's why I'm doing this. All right, let's do this. How do you draw the structure? Start from the right, move left. Toluene. Methyl group on a benzene ring. Don't forget the bonds for that cyclohexane ring, and I mark it all wrong. And there's a nitro group, which is NO2, and meta is 1,3, ortho 1,2 disubstituted, meta 1,3, para 1,4. 1, 2, 3, and a nitro group is that. And that reminds me, oh, I have to. And everybody know what that is. Paramedic. Ooh. All right. Now, at this point, I taught you that if there was something on a ring, it acts as a director. Actually, I didn't tell you we did a lab, but in this class, I'd rather spend things more germane to the rest of your life, because most of you are probably never going to do electrophilic aromatic substitution reactions or think about them after my class. Well, maybe, but it's rare, because none of you are going to become organic chemists, which I didn't expect. However, when you have a benzene ring or an aromatic ring, you don't break those pi bonds because they give you stability. And aromatic compounds are very stable because of that. Therefore, you replace one of the hydrogens on the ring with something. And the first reaction we have is halogenation. And you need a catalyst, ferric tribromide, and you replace one of the hydrogens with the halogen. And there are only two reactions I can give you on test, either one of those. Nitration, you take nitric acid, HNO3, sulfuric acid, and you put a nitro group on there. Now, common mistake, students do this, and that's wrong. It's NO2, not NO3. Next, we have sulfonation, sulfur trioxide, sulfuric acid, and you put on what's called the sulfonic acid group. And that's the only reaction I could ask you on the final, if I have that, because we're not doing substituents. And finally, one of those very special, very rare reactions, and that is Friedel-Crafts alkylation, named after two chemists, Friedel and Crafts, who discovered or invented this. I like invented better. They just didn't walk along the beach and say, oh, look what we found. They invented it. And here you take, and I taught you something that we've done. this says take A, react it with B and C, and you make D. And organic chemists are lazy sometimes. A lot of times we'll write our reaction that way. And Friedel-Crafts alkylation, you take an alkyl halide, and this is the first time I taught you R. Is this like in math where they use X, Y, and Z for variables? In organic chemistry, R means anything with carbon and hydrogens in it. 1, 10, 100, a million, whatever. Take an alkyl halide, aluminum trihalide, or X can be chlorine or bromine, and you form a carbon-carbon single bond. And the carbon on R with the halogen is the carbon in R here that's bonded to the benzene ring. Don't forget to put the double bonds or circle in the benzene ring. You know something? I should share. So I will. And remember, there'll be 2 synthesis problems. What 2 compounds do I react with aluminum trichloride to make that molecule? Your turn. That'd be 4 points, 2 points each. And since you may not have started studying for the final, I'll help you out. Folks, I didn't have to help most of you out. And I forgot to mention, don't forget, by the end of today is the deadline for the extra credit project if you're planning on doing it. And later this week, all those who submitted, I'll have it graded for sure by Friday, hopefully earlier. And don't forget about the lab amnesty program. I don't know when the deadline is, maybe today, and I'll extend it a day or 2 till Wednesday. If you're missing labs, hand them in. All right, let's do this. What's different? Ooh, a benzene ring with an alkyl group. This is R. How do we make that? This reaction, Friedel-Crafts alkylation. So one of the product starting materials is a benzene ring. Don't forget to put the bonds in there or circle. Then my R is 4 carbons. Which carbon is bonded to the benzene ring? The second one. And that's the one that will have Rx. Actually, that should be X. Most of the time it's chlorine because our X, when X is chlorine, is cheaper than Rx when X is Br, but it can be both. and therefore that carbon has a chlorine, 4 bonds to carbon, and that's my product. Now, while I remember let me just close this. Not that I get any kickback from this company, but it's the quickest way to find what I'm looking for. There's a great book, and you probably can get it from your local library, about, it's called Napoleon's Buttons, How 17 Molecules Changed History. And it's a great book. It's about time for me to reread it again. It's been a couple of years. Good books I go back and reread, just like you like to visit good friends. I do that. And this is a great book. And most of those molecules are organic. They have a great area on aromatic compounds, which wars were fought over that. And if you remember, some of those aromatic compounds we call spices. The German, Dutch, and English, and French, and Spanish, and Portuguese fought over where you could get those herbs and spices throughout the world. And that's test number 1 review. Remember, the files you're seeing on the screen are available in D2L in the lecture section, cleverly hidden as test number 1 review, test number 2 review, and so on. I had one student, where's your final review? Well, you take test 1 review, 2, 3, and 4, and that's the final review, except for amino acids, which is only 4 points, which I'll go over too. All right, let's start out. We talked about alcohols. Alcohols is a hydroxyl group on an R group. And how do you name it? You find the longest chain with the hydroxyl group on it, name it as an alkane, and then drop the E ending and add OL. For acyclic, you need a number. What carbon has the hydroxyl group? And that has priority over alkyl groups. When there's no number, when it's cyclic, there's no number, because if it's in a ring and that's the only functional group, which is what I kept to this class, then that carbon with the hydroxyl group is always carbon number 1. And everybody knows that, so you don't have a number. Now, there was a special alcohol when you have a benzene ring with a hydroxyl group, that's called phenol. No, not phenol, it's phenol. But I'm not giving enunciation quizzes, so you can do however you want to announce it. And this is another case of where IUPAC took the common name and made it the IUPAC name phenol. Don't forget the double bonds in the ring. Now, at this point, I talked about common name. And common name for alcohols, usually the smaller ones, name the alkyl group that the hydroxyl group is on, the R group, as a alkyl group, and then add the word alcohol. And remember, rubbing alcohol has 70 to 90% isopropyl alcohol, and the remainder is water. Now, this is the only reaction I could ask on 2 tests, which I did, and we just went over it. If you take a double bond reactor with acid and water, remember water is HOH, you break the pi bond, and one carbon of the double bond, one carbon of double bond gets H, the other OH. And that's Markovnikov's rule. Now you know carbon with hydroxyl group is an alcohol. Now, probably one of the more difficult, challenging reactions is this, and that is dehydration of an alcohol. You take an alcohol and it has to have a carbon adjacent to it with a hydrogen. Adjacent means next door. And this means heat and sulfuric acid, H2SO4. And you get a double bond, and it follows Zasev's rule, another great Russian organic chemist. And this is, you get the double bond or the alkene with the most carbon atoms directly bonded to the carbons of the double bond. Again, you get the alkene, the double bond that has the most carbon atoms directly bonded to the carbon of the double bond. And why don't you try this one? What would be the organic product or products for the following reaction? 3 points each. Remember, you get the alkane with the most carbon atoms directly bonded to the carbons of the double bond. As I've showed throughout the semester, these general reactions are building blocks that organic chemists use to make the things in our daily life. Looking at the clock here with the seconds, give you another 20 seconds, everybody, to finish. All right, let's look at this. What do we have that's different? Remember, always look at a molecule and what's different. And we have, an oxygen with a hydrogen and a carbon. It's an alcohol. We're reacting with sulfuric acid and heat, so I have to have an adjacent carbon with a hydrogen, and you lose water, and you form a double bond, and this follows Zasev's rule. I think I might have mentioned when I first started teaching, I'd be writing his name down, spelling it wrong. I tell you, I was first down in the spelling bee. I have to look it up and wasting time, and I decided just put down Z and say his name because we honor it. Now, Zayseff's rule is the carbon, the double bond with the most carbon atoms bonded to it is the carbon that you get. So here's our hydroxyl group. Adjacent carbons with hydrogens are here. Now, if I lose this hydroxyl group and this hydrogen from A, remember, you don't break carbon-carbon, single bonds. Oops. This is the compound I'll get. Now, if I lose this hydrogen from B in the hydroxyl group, between those two carbons, I'll have a double bond. And this is the molecule I'll get. Now, Zayseff's rule says the product you get, and I've modified it, in the real rule, it's the major and minor. For my class, I made it easier for you. It's the only one. You count the number of carbons bonded to the carbon's double bond. This one is 1. You don't count these because they're not directly bonded to carbon double bond. This one has 1, 2, 3. Now, hard math time again. Which is the larger number? And hopefully I'll pick B. 3 is the larger number. And this is the product you get. And that's how you do Zayseff's rule. Now, some other reactions. You take an alcohol and react it with HX, where X can be chlorine, bromine, or iodine. You replace the hydroxyl group OH on the carbon with the hydroxyl group with the halogen from HX. Now, since if you had a double bond, that could react with double bond. If you didn't want to, someone came up with, you take an alcohol, react it with thionyl chloride, you replace the hydroxyl group with a chlorine on the carbon that had the hydroxyl group. Next, I talked about oxidation. In general, the way organic chemists show a general oxidation reagent is a bracket O closed bracket. And what happens for a primary alcohol, remember, I didn't ask you to learn what's a primary, secondary, tertiary, but I taught you because I use those terminology. Primary alcohol, you oxidize, lose a hydrogen here and form a carbon-oxygen double bond, and you make an aldehyde. But at this point, you didn't know there were aldehydes yet. Next chapter, or 2 chapters. And if you take a secondary alcohol and oxidize it, you'll get the same thing, carbon-oxygen double bond. Now you get a ketone. Now, I didn't put down here, but I will now. Tertiary alcohol, you learned from the lab we did with alcohols, no reaction. Now, I've mentioned this before, but I'll mention it now. I have never, and I never will, put a problem on a test or a final where I ask you, give the product or products, and the correct answer is no reaction. No, if I'm going to ask you what's the product or products, there is going to be a product or products you get. No reaction will never, ever be a correct answer on any question on my test. Next, I talked about thiols. And thiols are the sulfur equivalent of an alcohol. Instead of ROH, you have RSH. And the two things you should know is thiols stink. They stink. Remember, skunk emits water, and thiols is its defensive weapon. If you've ever been around an animal or just an area that's got skunked, it stinks to all heaven. Anyways, really bad. The other thing I did teach you was, because of that tragedy in Texas in 1935, where I think 300 children and teachers died because of a natural gas explosion, which is methane. Natural gas methane has no odor, but a thiol, T-butyl thiol, is put in there to make it smell. And how stinky is that thiol? Well, they only put about 4 pounds of the thiol for every billion pounds of natural gas. And that was a question I had on test 2. Next, I talked about ethers. Ethers is R group oxygen, R prime. And I asked you to learn the common name only. Name each R group as the alkyl group, and then add the word ether at the end. The only reaction I asked you to learn was the Williamson ether synthesis, where you take an alkoxide, RO minus, Na+, reacted with an alkyl halide. X can be chlorine, bromine, or iodine. I think this is maybe, I don't know if this was or not. No, in alcohols, R prime is just like X and Y and Z in math. It could be the same or different as R. And you form an ether plus a salt. Now, the carbon in R prime with the halogen is the carbon in R prime in the ether that's bonded to oxygen. Well, let's have some fun with this reaction. And there you have R. Give the organic product or products for the following reaction. If you remember on test number 2, I even put this as a synthesis problem, which there'll be a couple synthesis problems on the final exam. All right, let's look at what's different. Ooh, carbon, but an oxygen, negative sodium cation, carbon-carbon halogen, R prime X. X can be chlorine, bromine, or iodine. And this attacks that and forms an ether plus the salt. And the carbon with the halogen is the carbon this oxygen is bonded to. You break carbon-carbon single bonds? No. So I have my ring, my CH2. This is my R prime. This is my R group. Doesn't matter which you put on either side of the oxygen. You could have the R prime. You could have also written it this way. And this is the carbon with the halogen. It'll be bonded to an oxygen. And that. Now, another way you could have written it, and I didn't want to confuse you, you flip the ring around so it looks like this. And the ether, same thing. I'm just flipping it. And these are identical structures. Left hand, oh, look, something different. No, left hand. And if I look at the clock, it's time to take a 5-minute break. I can get up and stretch again. Otherwise, my legs start feeling crampy, not crampy, just not good. And with that, let's take a 5-minute break. remind you, earlier I talked about how to calculate how many points you would need on the final exam, assuming you handed in all the labs to get a certain grade. Still, study like you need every point, because I've seen students not, and it hurts their grade, and I don't want to see that. Makes me feel better to see students succeed than not. All right, another thing, let me remind you, I'm going to extend, I was just thinking about it while I was doing my stretching exercises. Yes, I have some. I've learned. Did I tell you many years ago, I was playing tennis and I didn't know about stretching properly. And I ripped my calf muscles while I was playing, and the emergency doctor taught me about stretching. But anyways, back to while I was doing that, I said, I'm going to give you until Friday afternoon, 5 p.m. If you haven't handed in all the labs, get them in. There are points that help your grade. All right, let's continue with our review for the final exam. Next, I talked about epoxides. And epoxides, I only talked about one. This is an area I worked heavily in the chemical industry, ethylene oxide. And two reactions that I taught in this class, there are a number of others I could have, but I didn't. If you take an alcohol and react it with 1 mole of ethylene oxide, you get this ether alcohol. Now, if you take an alcohol and react it with N moles of ethylene oxide, you get this polyether alcohol. And I've worked for companies that make both. Now, this is one of the reactions, or pair of them, that I will never give a synthesis problem, but I can give a regular problem. And the question would be, give the organic product or products for the following, 3 points each. And I hope you're finding this review helpful. And the good thing is, if you want, you can go back and watch it again once I post the video on my YouTube channel. And just in case you forget, well, I don't think so. I don't have to do it. Let's see. There's a little help for you. All right, let's go ahead and do this. You look for what's different, what's not carbon, what's not hydrogen, What's that, a carbon-carbon single bond? Should have gotten your attention like that. Oh, we've got an alcohol. Hydroxyl group on a carbon. And I'll call this R. And we have, 7 N moles of ethylene oxide. And you get this polyether alcohol. And what is my R group? C-butyl group. The carbon with the alcohol is the carbon and R that this polyether is bonded to. What's N? 7. And remember, the hydroxyl group goes outside the bracket, not inside. That's a common mistake. And I'll say it again. The hydroxyl group goes outside the bracket, not inside. If it's inside, I mark it wrong, because it is. And I taught, if you go back and look at the videos, some uses for these types of molecules, and I've done that throughout the whole semester. All right, next, see the smile on my face, talking about one of my comfort functional groups, because this is what I did my PhD thesis on, ketones and aldehydes, and I also, my first and last patents dealt with, US patents dealt with aldehydes and ketones. So Dr. White and Mother Nature loves aldehydes and ketones. Aldehyde, carbon, double bond to oxygen with a hydrogen R group on that carbon. Ketone, carbon, double bond to oxygen with 2 R groups on the carbon. Now, how do you name a aldehyde? Find the longest chain, and this is called the carbonyl carbon, which you'll see in a second, and name it as an alkane. Drop the E, add Al. Remember, alcohol, OL ending, aldehyde, Al. On your test, when you print these, make sure I'm not guessing. Is that an A or an O? Because I might guess wrong. But anyways, and this is called the carbonyl carbon. Dr. White loves carbonyl carbons. They've been good to me. I've been good to them. And the carbonyl carbon is always number 1 in aldehyde. Everybody knows that, so there's no number. You cannot have an aldehyde in a ring. Now, for a ketone, you find the longest chain with the carbonyl carbon, carbon double bond to oxygen, name it as an alkane or cycloalkane. Drop the E, add ONE. If it's acyclic, not in a ring, you need a number, and that has priority, always gets the lowest number, because carbonyl carbons rock, and they do. And if it's cyclic, no number, because the carbonyl carbon always is number 1, always. What I haven't taught you is when you have more than 1 functional group, IUPAC has rules, which one is higher priority and which one gets the lower number. Example, a carbonyl always will be lower than an alcohol or a double bond. But I didn't teach that. Give the IUPAC name for the following molecule. Your turn to have some fun. You notice I said fun a lot. I've been brainwashing you there too. If I say it a lot, you might believe me, but it is true. All right, let's take a look at this. What do you do? Look for what's different, what's not carbon, what's not. Ooh, oxygen, double bond to carbon, hydrogen, R group, aldehyde. And how many carbons is the longest chain with the carbonyl carbon? Carbon double bond to oxygen. 1, 2, 3, 4. Down here would be 4. That's butane. Aldehyde. A-N-E ending. Drop the E, add A-L. Butanal. This is 1. I don't need to put that there. Oh, it's your old friend, the methyl group on carbon 3. 3-methyl butanal. And why don't you draw the structure of 4N-butyl cyclohexanone? All right, I think everybody's done. Let's take a look at this. How do you draw this? How do you decode it? Start from the right, move left. O-N-E ending, ketone. And if that were an E, cyclohexane. Oh no, I'm having a bad ring drawing day, sorry. Let's try that again. And then I'll have my carbonyl, because this tells me there's a carbonyl is in the ring. That's carbon 1. You can go clockwise or counterclockwise. And on carbon 4, it doesn't matter which way you draw the carbons, an N-butyl group. I could have had them going this way too. And that's 4N-butyl cyclohexanone. Now, there are 2 common names I asked you to learn. The simplest aldehyde, when R is a hydrogen, is formaldehyde. And you could have also written it this way. And that's the simplest aldehyde. And as I showed you, I worked with that. My last patent dealt with that. And I also talked about, which won't be on the final exam, the problems using that in wood from China and what happened with the Katrina trailers from Hurricane Katrina or afterward. Now, when the simplest ketone, nobody calls 2-propanone, it's acetone. And that's the simplest ketone. Remember, this is a ketone. And remember, this is one of the two molecules that's nail polish remover. Until they came up with the new super hard nail polish that you cure under a light to make it harden, most of the nail polish sold in stores, big box stores, or wherever, was acetone. Then with that, it was another one. Now it's acetone is the most, because this does a good job. Now, I asked you to learn what is the carbonyl group, how do you describe it with a picture, draw it, and how do you describe it with words. And on test 4 points, describe the carbonyl group with words and drawing. The carbonyl group, carbon, double bond to oxygen. And you write it, carbon or carbon atom, double bonded to an oxygen atom. I know of nothing more important to me personally in all of organic chemistry. Wow, that's a heavy statement. And as we talked before with alcohols, you take a primary alcohol, oxidize it, you get an aldehyde. Secondary alcohol, you oxidize it, you get a ketone. And what would you oxidize to make that compound? And since you might not have memorized or remembered, I'll help you out today. And there you go. If we were in normal lecture, you would have seen the general reaction on the screen already from the first problem I would do. If you go back and look at the videos, I always did that. I did one, write the general reaction, but you try one or two. Am I nice or what? Don't answer that. All right, let's take a look at this. What's different in the product? It's not carbon, that's not hydrogen. Ooh, an oxygen, double bonded to carbon with carbons here and here. This is a ketone. And what do you oxidize? That's what O in the brackets mean. To make a ketone, a secondary alcohol. Now you can say this is my R prime, and this part is my R double prime, and they're just connected together in the ring. So if I end up with a ring with this carbon, I better start with the ring with the methyl groups on it where they are. Now the carbon here is this carbon, which is the carbonyl, which is the carbon with the alcohol. And that's how you do it. Now, next, I showed you a really good reaction, which is, well, they're all good. I showed you this semester. I didn't show you any bad ones, is Friedel-Crafts acylation. And Friedel-Crafts acylation is if you take a benzene ring with an alkyl chloride or acid chloride, I'm sorry, and aluminum trichloride, and you make a carbon-carbon single bond, and you make an aromatic ketone. And those have many uses, including sunscreens. Now, the next four reactions were a little challenging, and I also promised I would never give a synthesis reaction. First one, if you take a ketone or aldehyde, and this is a way, if R prime is hydrogen, it's a aldehyde. If R prime is carbons, it's a ketone. And if you react it with an alcohol and acid catalyst, keep your eye on the carbonyl carbon. That's where the fun is. And what's attached to it, R prime and R double prime, stay there. You break the pi bond to the carbonyl. And I should have mentioned this. Carbonyl has a pi and a, I never asked that on test, but both of those you can break, unlike carbon-carbon's sigma bond is very rare to break. And you have on that carbon an alcohol plus an oxygen with an R group, and that comes from this alcohol. Now, if you use two alcohols, 2 moles with an aldehyde or ketone, you'll get this. These are called hemiacetal hemiketals, which I didn't ask you to learn. And these are called acetal or ketal. And you learn later on that second reaction or variation thereof is useful in making starches. Now, a special case, which I talked about, my advisor's advisor, Dr. Stork, came up with putting on a protecting group, reacting a aldehyde or ketone with ethylene glycol. And notice this has not 1, but 2 alcohols. So this is like this. And you get this molecule, which you can easily take off that group when you don't want. You're reacting that molecule with something that would react with the carbonyl and you didn't want to. And don't forget, you don't break this carbon-carbon single bond. Students forget to put that in there, and I mark it wrong, which I did on test number 2. Now, once you make the hemiacetal or hemiketal in equations 3 and 4, if you take acid and water, like in your stomach, hemiacetal, hemiketal, you get back to ketone and the aldehyde plus the alcohol you would have used to make that hemiacetal, hemiketal. And if you take the acetal or ketal, acid and water, this is how your stomach breaks down starches, you get back to the aldehyde or the ketone plus the alcohol, and you don't have to put a 2 there because we don't balance equations in this class to make that acetal or ketal. Now, one of my heroes in organic chemistry, Victor Grignard, won the Nobel Prize for a series of reactions, first discovering his or creating his Grignard reagent. Take an alkyl halide, react with magnesium, and what do you get? You get the Grignard reagent right here. Now, what can you do with a Grignard reagent? And this is what makes it so special. You can make carbon-carbon single bonds with ketones and aldehydes. And the Grignard reaction, which one of the 2 reactions, besides making the Grignard reagent, he won the Nobel Prize for back in about 1910, give or take 5 years. And here, take an aldehyde or ketone, react it with the Grignard reagent second step, acid and water, and you make a carbon-carbon single bond to the original ketone aldehyde, you open it up to an alcohol. And this is a reaction I'll never give a synthesis problem on. And since you might not have studied this in a while, I'll write the general reaction underneath. And why don't you give what would be the product for that reaction? For some reason, on test 2 and other places, students have problems with this reaction. And please be patient. Let's give everybody time to finish. Finish. Just think, in a week or so, unless you happen to watch my videos, you don't have to put up with my bad humor anymore. Or good humor if you liked it. All right, let's take a look at this. What's the product or products that are following? What's different here? Oxygen, double bond to carbon, carbonyl. Carbon's here and here. It's a ketone, where R prime is carbon, it's not hydrogen. What's different here? Carbon, carbon, carbon. Oh, magnesium halide. This is a Grignard. And this is my R triple prime. I can call one of these R prime, one of these R double prime. Notice carbonyl, what's attached to it is still attached to it, R prime, ethyl. R double prime, methyl. Hydroxyl group. What's R triple prime? Notice the carbon with the magnesium chloride will be the carbon bonded to this. And you don't break carbon-carbon single bonds. And that's how you do it. And now with two simple molecules, this is very easy to come by. This is easy to make. You have a very complex alcohol, which you can do other things with. Now you see how a synthetic organic chemist looks at reactions. Now, as I mentioned earlier, carbonyl has a pi bond and a sigma bond. And just like with a carbon-carbon double bond, carbon-oxygen double bond can be broken with hydrogen and a catalyst, and each atom of the double bond gets a hydrogen. Now, this could react with carbon-carbon double bonds, which you didn't want to. So H.C. Brown came up with the following reagent, which he did win the Nobel Prize somewhere in the late 1970s, not that long ago. But it took a while for them to give it to him until a lot of organic chemists complained bitterly because he discovered lithium aluminum hydride, LiAlH4, near the end of World War II, about 1945. And if you take an aldehyde or ketone, react it with lithium aluminum hydride and second step acid and water, you get the same product. You break the pi bond between the carbon and oxygen, and each atom of the carbon oxygen double bond gets a hydrogen. Now, this will only attack carbonyls. It won't attack carbon-carbon double bonds. So that's why it's a useful reagent. Now, next I talked about the aldol condensation. And the carbon attached to the carbonyl has acidic protons, and it's called the alpha carbon. And you form the enolate anion that attacks another aldehyde in the presence of base and water, and you form a carbon-carbon single bond, opens this up to an alcohol. And this is called an aldol condensation. Aldehyde, you can do it with ketones, but I don't in this class. Alcohol, OL, aldol. And my gift to you is organic chemists at my level would never write two of these. We just write one and not even put a two in front because we don't balance things. And there you go. And since you might not remember this, I'll help you out. And there you go, a little help. Isn't that one of the Beatles songs, a little help from your friends? I think I told you my real claim to fame. I saw Jimi Hendrix live. I saw Gracie Slick in the Airplane live. If you don't know who those are, well, look at my list of songs you should listen to. And this is a reaction I will never give as a synthesis problem. All right, my turn. What do we have here? Two aldehydes, and they're the same. That's my gift to you. And the alpha carbon has acidic protons that form the enolate anion. Excuse me. The NaOH, let me write it a little better, takes it off, and this attacks the other carbonyl carbon. Here I can say that's my R group. What's attached to it still is attached to it. Take off one hydrogen. This bonds to this carbonyl, opens it up. Remember, 4 bonds to carbon, so you have to break that pi bond. And what's attached to it, CH2, CH3, is attached to it. And you've made that carbon-carbon single bond, something very special, very rare. And we're done with the material of test 2, but I'm going to come back. I sort of skipped over it, but let's go back and look at these 4 reactions. And let's look at number 1. And I'll give you the general reaction. And why don't you try it? What would be the organic product or products for that reaction? And I'll never give you a synthesis for this one. All right, let's do this. What's different? Ooh, carbon, oxygen, double bond to carbon, hydrogen here. We have an aldehyde. It could have been a ketone. Carbon, hydroxyl group, alcohol, acid catalyst. This is my R prime. This is my R double prime. And this is my R group. Keep your eye on the carbonyl carbon. That's where the fun is. What's attached to it? R prime hydrogen, R double prime, 2 carbons. It's still attached to it. We'll have an OH group, oxygen. What's my R? Methyl. And that's how you do it. In case you want to check, I'll give you another 20 seconds. I'll give you 30. I'm generous today. Oh no, it's Bad Humor Monday. All right, let's do another one. Again, I'll help you out. And there you go. Give the organic product or products to the following. All right, let's take a look at this. What do I have here? What's different? Ooh, oxygen double bonded to a carbon in a ring. That's a ketone. Where R prime and R double prime are the ring plus the methyl group. What do I have here? Methyl, CH2, CH3, CH2. Ooh, OH on a carbon. That's an alcohol. This is my R group. Keep your eye on the carbonyl carbon because that's where the fun is. What's attached to it, R prime and R double prime, which is my ring with a methyl group. That's this carbon right here. Yet this carbon, which is this carbon, you don't have to draw the C on the ring, but I'm showing you, we'll have two oxygens. What's my R ethyl? And that's what you get. Everybody got that copy down? Who wanted to copy it down? Give me a thumbs up if you're done with this slide. See, one person, 2, 3. I guess everybody's done. If not, go back and look at the video. And with that, if I look at the clock, and I just did, oh, that was hokey. It's about time to call it quits for today. Wow, time flies when you're having fun with organic chemistry. Now, remember, a week from today will be the final exam. Study the reviews, do the practice problems. Now, one way you can do practice problems is use your hourly exams as practice problems. I went through the right answers, excuse me, and will I put the same problems on? No. Will I put similar ones? Of course. Look at my practice problems. Aren't they similar to what I put on the exam? Yes, by choice. And with that, I can remind you, if you have any questions, you can always email me. Don't forget, Tuesday and Wednesday from 6 to 7:15, I have office hours on Zoom, so you can always come there. And remember, hand in your labs. With that, I'm going to let you out. Don't tell anybody. Almost 2 minutes early. And with that, I'll say "Gehen gesund," that's Yiddish for going out, and goodbye. I stole that from Granny and the Beverly Hillbillies. Bye, everybody.